Hey physics students, I'm going to make a little video for you here. Well, I guess I'm already making it. I'm not going to make it. It's already in progress. It's going to be about units. On your pacing guide, I think I called this dimensional analysis, but I think that's really not the right name for it. I think that really all we're doing here right now, at least, is unit conversion. But you could call it dimensional analysis. You might have seen it called that or heard it called that in unit conversations. See, this is what happens if you talk and write at the same time. I should have more practice, but we're not talking about unit conversations. We're talking about unit conversions. That's better. All right. Glad I caught that one. That was embarrassing. So we take a lot of things for granted, like inches and miles and ounces and pounds and seconds and hours and all these different things that we measure and that we have units for. But all of these things that we use are really arbitrary. Like there's nothing that makes a second really what it should be, except for that's what we decided is going to be like our fairly small unit of time. And why did there have to be? Why does there have to be 60 of them in a minute? Well, that's just an arbitrary decision too. So all these things are made up by humans. And humans in different places might make up different units. So we need to be able to convert units from one type of unit to another one so that we can compare and actually have meaningful conversations with other people. I guess that's unit conversations. There you go. So what are our units? The things that we're going to be interested in measuring in our little corner of physics are length and mass, not weight, that's different, mass and time. And the SI unit for each of those, this is the International System of Units. If you're wondering why the letters are backwards, why isn't it IS units if it's International System? It's because it's from the French. That's where the International Bureau of Weights and Measures is located, I think somewhere in or outside Paris. And in France, instead of saying international system, they say Système International. So that's why it's SI units. So for length, the SI unit is the meter, which we abbreviate with a small m. For mass, the SI unit is the kilogram. And you might be wondering why the base unit, the SI unit, would be something with a prefix. And the best explanation that I can give you is up until very recently, the standard, the accepted standard for the kilogram was a physical object that was kept in Paris. I actually have, hold on, I've got a picture of it in this article here on my bulletin board in the back of my room. If we were all here together, you could just come look at it, this article. And this article is about the kilogram being redefined. This is from less than 2 years ago. So I don't know if you can see in this picture. In the middle of this, it's kind of hard to see. There's a cylinder down here. There's a cylinder. It's a platinum iridium cylinder that was like the standard for the kilogram, and it's kept under all these jars in a vacuum so that little tiny atoms won't go attaching themselves to it, or vice versa. It basically looks like this. Here's one of the copies. This is, I guess, technically like a copy of it that I have. And you can see about how big that is in the palm of my hand. This is 1 kilogram. It's pretty dense. It's probably, if I could put it into your hand, you'd be like, oh, that's a little heavier than it looks. but this is 1 kilogram. We measure, that's a measurement of mass. We measure weight of things. We talk about weights a lot and pounds. That's really a measurement of force. But the gravitational force on 1 kilogram is about 2.2 pounds. So if you put this in your hand or if you put it on a scale, 2.2 pounds. So the reason that our base unit has a prefix and isn't the gram is a gram is a very, very small amount of mass. It's not very like human scale, so it would be hard to have like a really accurate one of those. It would be very, very small. I'll show you what a gram looks like real quick, because I have a really cute one. Let's see. Oh, I hope all my 1 gram ones aren't lost. The 1 gram ones are very small, so they're prone to getting lost. So this is actually, you'll have to use your imagination. This is actually 2 grams. And you can see, just for scale, there's my pen. Isn't that cute? It's like a little tiny version of the big one. That's 2 grams. So half of that would be 1 gram. That's a little bit of math there for you. All right, so that's that. Time, the SI unit for that is the second, 1 second. We abbreviate that with a lowercase s. So when I ask you on the first, your first assessment, if I ask you what is the SI unit for each of these things, these are the answers. And the one that most people trip up on is the kilogram because of the kilo prefix. Okay, so what we're usually interested in doing is converting things into these units. Sometimes we're interested in converting from these units to other units. That can happen, for sure. And we're also interested in being able to put metric prefixes on these things to make them bigger or smaller as needed. There's a whole bunch of metric prefixes, and I know that you have learned them in other science classes. I'm going to write down some right here. The biggest, well, I'll tell you which ones you really need to know for my classes. Let's go from, how about, since we do a lot of computer stuff, we'll do giga, mega, kilo, and then you have your base unit. Your base unit could be a meter or a second, whatever you're attaching your prefixes to. And then we have centi and milli and micro and nano. Now all of these, except for micro, the metric abbreviation for the prefix is this first letter. Notice that this is a lowercase k, not an uppercase k. This is big G, big M, and then this is small k, small c, small m, small n. Micro, you can't use the M because you just used it for milli, so the convention is to use micro. It looks kind of like a U. You could probably find it on your computer somewhere in the special characters, the Greek letters. It's the Greek lowercase mu, and I think that's a pretty good version of it. So it looks kind of like you're trying to do a cursive U, but with this long trailing front edge. Will do just fine. And I mean, it sort of vaguely looks like an M, right? Kind of has the 2 bumps, whatever, so micro. That's that one. And now what do these things mean? Kilo means 1,000, which is 10 to the 3rd. Mega, you ever heard of Mega Millions, the lottery thing? Well, that's a good way to remember that. That's 10 to the 6 is mega, and giga is a billion. Right? And we talk about, when we're talking about computer memory storage, how big files are, we talk about megabytes and gigabytes a lot. Back when I was a kid, I did actually have a computer. I think when I was maybe like 12 or 13, I got my first computer. I was kind of a on the leading edge of nerdiness then, so I was one of like an early adopter of kids getting computers. But we were all dealing with things, memory that was like kilobytes back then. And then there's terabytes if you have like an external hard drive or something. Like a lot of things are being measured in the next one up there, terabytes now. All right, going the other way, so that's like lots of things, 1,000, a million, billion. If you want to break things into smaller bits, you have nano, which is 10 to the negative 9. A lot of n's there. Nano, negative 9. Micro is 10 to the negative 6. That's a millionth. Milli is a thousandth, like millimeters. And then the only thing, you notice that these are all multiples of 3, 369, 369. The only one that is not, that we're going to use regularly, is centi. And probably you're familiar with that one. Maybe you're familiar with that the most because it's the one that we see a lot in just measuring things like, how long is this pen? Well, this pen looks like it's about 13.8 centimeters, or 138 millimeters. And then, of course, there's inches, which are awkwardly divided into halves and quarters and eighths and sixteenths. But, hey, I guess we're sort of used to that. So centimeters, although it's unusual that it's the -2, it's one of the prefixes that we'll use more than anything else, and we will use it specifically with meters a lot. All right, so how do you convert from one of these to another? You might have a way that you learned from some science teacher or other somewhere along the line, and if you have a way that works really well for you, and you're very confident about doing it that way, I am 100% okay with that, and I don't want you to change anything that you do. But, on the other hand, if you still feel a little squishy about being able to do this, I'm going to show you how I think about it, and I'm going to try to show you a very consistent way of doing it. So if you're not interested, because you already know how to do this and you're happy, then you can scrub forward in this video. Otherwise, check this out. So let's say, let me do some examples. I want to convert 3 kilometers, so that's the K plus the M, that's kilometers. I want to convert that to meters. Now, if you just look at this and you're like, oh, well, that's 3,000 meters. You know, that's great, that's fine. I'm very happy for you. But sometimes we get a little bit confused. Sometimes these can be more complicated. So I'm just going to show you how to sort of methodically do this. So I'm starting with 3 kilometers. I'm going to put that over 1, because that's what I'm starting with. I'm going to write everything out as little fractions. And now, I want to multiply this by a conversion factor. But of course, if I want to multiply by something and have it not really change how big this is, just be in different units, then the conversion factor has to be something that's equal to 1. I basically have to multiply by some version of 1. Now, what I would like is for the kilometers to cancel out. If that's going to happen, the kilometers have to be on the bottom, and I would like to get to meters. So now, right now I have a kilometer on the bottom and a meter on the top, and those are not the same thing. But I know that a K, what is that? That's 10 to the third. So if the K shows up down here, I can put a 10 to the third here, and those are like two things that are equal to each other. The K is here, the 10 to the third is here. Well, that's what K means. So this, right now, the M's, same, the K, same as the 10 to the third. So those cancel out, and I get 3,000, or 3 times 10 to the third meters. All right? So you can do any conversion, moving from some prefix to some other prefix in this way. Let me do another one. Let's say we have, how about 2.5 times 10 to the 17th nanoseconds. Gee, that sounds like it could be a long time. I don't know. Let's convert that to... let's do nanograms for this one. I want to do another example with seconds in a minute. Maybe I'll use the same number. We'll see. So let's do nanograms to kilograms. And I know you might have a way of like counting how many places to move the decimal and all that. That's fine. If you can do it that way, that's great. But I'm going to show you how to do it this way. So I've got 2.5 times 10 to the 17 nanograms. That's where I'm starting. I put that over 1. Okay, now before I go to kilograms, I'm just going to go to grams. So I would like nanograms to cancel out, and I would like grams to show up. And nano means 10 to the negative 9. So those are canceled out now. But now I'd like to get from grams, so I want that to cancel out, to kilograms. And the K means 10 to the third. So I put that here. And then I multiply that all out, and I should get 2.5 times 10 to the fifth kilograms, if I didn't do any bad math there. Pretty sure that that is right. And that's how you move from prefix to prefix. You also need to know some basic conversions from our units. Oops, let me slide that over so you can see what I was doing over there. Good. Okay? And I'm going to have you can just hang tight here for 1 second. You might have to scrub through the little bit of this video. I need to check my computer. I think somebody might have just popped into a Google Meet that I thought was going to stay quiet. I'll be right back. Aiden.
Hello.
How you doing?
I'm doing pretty good.
Good. What can I do for you?
I don't know. I was just kind of going to see if we talked about anything like. Well, I feel like I jumped out of your panel what we have going on.
Excellent. I checked in a little bit late today, so not too many have stopped by to the Google Meet. And if you're feeling good about everything, then keep on keeping on and keep me posted about your progress. And
Alright.
I think you're good.
I was just checking in to see if we were talking about anything.
All right.
Have a nice day.
Okay, you too. Thanks for checking in. Hey, folks. So, I'm back. Sorry about that little pause there. But, all good. Now, what if you have to do conversion from some of these things, but then also to other units? Like, for example, do you know how many meters there are in 1 mile? Well, let's see. I do. It's about, if you run track, or you know people who run track, or you ever gone to a track meet, there's a 1,600 meter race sometimes, which is really awfully dang close to a mile. It's really about 1,609. It's not exactly that. It's 1,609. That is to the nearest meter. That's a good conversion to know. I'll probably give you that if you ever need it. Here's some conversions that you just need to know because you are a resident of this country. You need to know that there are 12 inches in a foot. You need to know how many feet there are in a mile. If you're like, whoa, I don't know that. Well, hey, this is one of the prices we have to pay for being Americans and not being on the metric system. We have to know our own weird units that the rest of the world doesn't use. So how many feet are there in a mile? 5,280. Now the whole world is on the same time system, so we all know that there are 60 seconds in 1 minute, and there's 60 minutes in 1 hour, and there's 24 hours in 1 day. So all of these things, when two things are equal to each other, it means you can make a conversion factor out of them. Like you can put 5,280 feet over 1 mile because they're equal to each other, and that means that fraction is equal to 1, and you can put either one on the top, and that will work for you. So I'm just going to do maybe 2 more quick examples, and then I'll leave you alone for a while. So how many, how about if we convert 100 years to kiloseconds? That's a weird measure, a kilosecond. A kilosecond is just 1,000 seconds. We don't use kiloseconds as a measurement because we have hours, which is like kind of the same scale. An hour is 3,600 seconds. So kilosecond's about, I don't know, 18 minutes or something? Who knows? I guess we could do that as a problem too, convert kiloseconds to minutes. 100 years to kiloseconds. Let's give that a shot. So we start with 100 years over 1. Now I want to get to, before I worry about the kilo, I just want to get to seconds. So for years, I don't know how many seconds there are in a year. I need some steps in between. I do know that in 1 year, oh, here's another one you need to know, that in 1 year, do you know how many days there are? If you're thinking to yourself, yeah, duh, everybody knows that, you would be surprised how many people do not get that right. And if you're one of the people who didn't get it right, you have plenty of company. But we do need to know that. So that gets me to days, and let's see, how many seconds are there in a day? I actually happen to know that number because I'm a physics teacher and it comes up often enough, but you probably don't. So let's see, in 1 day, I do know that there are 24 hours. I know that. So now I got down to hours, and then maybe, do you know how many seconds there are in an hour? There's 3,600, but if you didn't know that, 60 times 60, then you could go to 60 minutes first. Now I'm at minutes, and then I go from 1 minute to 60 seconds. So in setting up this little chain of fractions, you just have to make sure, I mean, you've taken Algebra 1, you know when you got something on top and on the bottom, those things cancel out. You have to make sure things are set up so that they will cancel, and make sure that you're putting these numbers in the right place. Like don't have 60 hours is the same as 1 minute, for example, because that's just wrong. So that gets me to seconds, but I actually want kiloseconds. So now I'm going to do the same thing I did in the last examples on the previous page. I want to get rid of seconds, and I want to have kiloseconds. So kilo means 1,000 10 to the third. So those are equal to each other, those are equal to each other, and I'm good. Just need to flop down my calculator and do the math. 100 times 365. Should I hit enter here? No. If you're one of these people who likes to hit enter after every single calculation, just let's go ahead and knock that habit in the head and stop doing that. Put the whole thing in. you paid for this fancy calculator, or stole it from the school or something. So let's use it to its full potential. 10 to the third. So there we go. It is, and you know, that number, I'm like, oh, where do the commas go? Let's see, 3,153,100. So I can put the commas in, and that is kiloseconds. I could do that if you're like, oh, I would like to write that in scientific notation. If you know how to do that, you probably do. So 1 there, sorry, times 10 to the 6 kiloseconds. You can also, in the mode options of your calculator, the second one right there, SCI, that's for science. It's actually for scientific notation. I can do that, select that, enter, and go back here. Now it didn't do it yet, but if I hit enter again, it will now make that number in scientific notation. The only thing is, you are not allowed to write that E. You have to write times 10 to the. This is the way humans do it, and the E thing is just how the calculator does it. That's what that E means, times 10 to the 6. We don't write it in calculator language. We write it in human language. All right. If you've got a fancier, more recent edition of this calculator, you might have one that actually writes it, makes it look better than that. So that's an example there. And the last thing that I want to do is one example where we have higher dimension units. For example, what if you had a room that was advertised as being, let's say, 10 cubic meters? And you're like, well, I don't really know what that is, but I think I have a pretty good idea what square feet are. Because if you're looking at the floor of my classroom, those little tiles we have, those linoleum tiles all over the school, those are 1 square foot, each one of those tiles. So maybe you want to convert that to, oh, I had to put cubic feet here. I meant to say square. Sorry about that. 10 square meters. I would like to convert square meters to square feet. All right? So let's see, 10 square meters over 1. And, I don't really know where to go from here because I don't know a conversion. You could look it up, I guess, but that's sort of cheating. Not really, I guess. But I don't know, maybe I should, exactly how many feet there are in a meter. It's 3 and change, I do know that. But I don't know, it's like 3.29, I don't know, whatever it is. But I do know this, there's a workaround here. I do know that if I want to get from meters to miles, 1 mile, I know that there's 1,609 meters in 1 mile. But I need square meters. So that means I need to square this stuff. And that means that this thing also gets squared. This is a little thing that trips people up when they're converting square or cubic units. So that number is going to have to get squared. This one, that doesn't get squared because this is 10 square meters. This is 1,609 meters, just straight line. If you want to make that into a square, then you got to square the unit and the number. This was already done. All right. So I got that. Now I want to go from miles to feet. So I know 1 mile, 5,280 feet, but I need square miles and square feet. So when I do my little multiplication here, I need to, this one is all set, that's good, times, divided by 1,609 squared times 5,280 squared. And there it is in scientific notation. That's 1.0, I'm going to round to the nearest hundredth there, 1.08 times 10 to the 2 square feet, or also known as 108 square feet. If you have a number in scientific notation and you want to get it out, then you can do the same thing. Mode, go back to normal, and go back to your home screen and hit enter again. There you go, 108. If you want your calculator to round things, this where it says float and then there's a whole bunch of numbers, if you want it to round and have like 3 significant digits or 2 or whatever, then you can choose that and go back to your home screen. And oh, that's doing 3 decimal places. Interesting. So if you want to do 3 significant digits, then you'd have to do scientific notation mode and pick a number here. So that will give you 3 there. I guess that's 4 significant digits. So you can get your calculator to round for you also. And there you go. If you want it to round to the nearest unit, then you can go into your mode and do 0 decimal places. And go back to, sorry, I should have also gone back to normal. So there's ways of tweaking your calculator to get it to give you an answer that looks like what you want. 108 to the nearest square foot. All right, there you go. There's some notes about that.